for you to understand the course and to be part of the course very actively. So these are my few suggestions for you people at the start of the course, so that it may become very easy for you to understand various different aspects related to the power system or power system analysis. Fine. So before introducing you about the power systems or power system analysis, I would actually discuss with you what are the PLOs and what are the CLOs of this course, and what will be the entire course outline that we will actually discuss in 16 weeks of this course. Fine. So I have made these few CLOs and PLOs of the course. I will display it in your screens as well, so you can easily see there. I have been teaching this course since 2014 in UET Text Lab, and almost all the batches after that I have taught them this course, and Alhamdulillah, you are also one of them to whom I will teach this course. So I teach this course with utmost my motivation, skills, and try to impart maximum knowledge as much as I can in my students. So I would also expect this from you, that you also pay your efforts, try to involve in the course, ask questions. If you will ask questions, actually you will learn more and more. So now I will share my screen with you so that you can see the file that I have currently opened, which is about the CLOs and PLOs of this course. I hope you all can see my screen on your computers and laptops, as well as on your mobile phone, the students who are taking the class on the mobile phone as well. So can you see my screen?
Yes, sir.
Yes, sir.
Okay, that's good. Now, the prerequisite for this course is electrical network analysis, and with the passage of the time, when we will go in details of this course, you will easily understand that why electrical network analysis was important for the understanding of this course. Now, there are three course learning outcomes that have been designed for this course. The learning outcome basically demands that you must understand the fundamental concepts, definitions, and significance of electrical power systems. First of all, we will have this objective or course learning outcome that we want to attain after studying this course, and this has been mapped with PLO1, which is actually about the understanding about the fundamental concept. Then we have CLO2, which is about analyze load flow, fault, and stability analysis of power system. And this has been mapped with PLO2, and PLO2 is about complex problem solving. So we will also solve various problems to understand the concepts that we have grabbed in CLO1. And thirdly, We will also try to achieve the outcome number three by solving or applying these methodologies that we have learned, that we will learn or we will understand in the entire course by applying them on the different power systems, practical systems, and perform different hand calculations. And this CLO is made with PLO 5, and PLO 5 is about modern tool usage. And modern tool usage is basically covered in this course in the form of by making you understand how to basically solve and design power system on MATLABs and few power system simulation tools such as electrical transient analysis program ETAP and power system simulator for engineers. So these are the modern tools that we will use in this course as well. Therefore, we will also cover PLO 5. So there are three PLOs that we will cover in this course. PLO 1 is about fundamental concepts. PLO 2 is about complex engineering problem solving. And these three PLOs will be attained through by doing all these things that are our three CLOs. And all of these are basically aligned with the cognitive domain of the Bloom taxonomy. So therefore, I hope you have now got the understanding that how the CLOs and PLOs of this courses map. So again, I have also given the details of these PLOs. So here it is written that PLO 1 is about engineering knowledge that is mapped with CLO 1. PLO 2 is problem analysis that is mapped with CLO 2. And PLO 5 is about modern tool usage and that is aligned with PLO 3, CLO 3 or mapped. So these are the recommended books. I hope you can see the books, recommended books on your screen as well. First of all, you all should have Hadi Sadat, Power System Analysis by Hadi Sadat, and this book is easily available in the market. It is also available at the old bookshops because most of the previous batches they have used this book and in the other universities as well. So if you go to the here southern market in Rawalpindi or commercial market or any other market where old bookshops are available, you can easily find out these Hadi Sadat books there. Otherwise, I would recommend you to, if you will not be able to get any old book in good shape, then I would recommend you to buy it. And but every student in the class should have the book with him or her, and I would check the book as well when you will be physically available in the classes. So this book will be serve as the main major fundamental book or the textbook for you in this course of power system analysis. Which book? Its name is Power System Analysis by Hadi Sadat, and it has been published by McGraw-Hill International. Second book that is also that will serve as a reference book, which is about power system analysis by Gulliver and Sharma. This is also a very good book, and it is also available in the market. Maybe not in the pirated form, but it is available in the original volume. So you can also buy it, or you can have it also from the internet in the form of soft book. Then we have also a reference book. We will study that Power System Analysis by Stevenson Granger. Uh, Again, this book is available in the market, and I have also soft copy of this book. If anybody wants, I will upload these books on the teams of our class as well. Moreover, interestingly, this book, which is I have named the Power System Analysis by Stevenson Granger, its 180 copies are also available in the library as well. So you can easily issue it from a library from a university. Almost 180 copies are available there. So I think maybe 180 students are registered in the class as well. So you can easily get it from the library as well. But its soft copy is also available, and I will upload that. Then fourth, we will also discuss electric power systems by B.M. Reddy, B.J. Corey, and N. Jenkins. So these are the four books. Number one will be your textbook, and 2, 3, and 4 will serve as a reference book for the entire course. And these are not just written here as a reference book or just by putting the name that we have to increase the number of the books in the recommended books portion of the course information file, but we will use actually these books in our course, and I will try to actually make you understand different concepts by having the data or by having the concepts from these books as well. So I have written the names of these books here, the reference books here, because they will be actually involved in the course, and maybe some concepts, and we will discuss some concepts from these books as well. And time to time, I will actually inform you as well that I am discussing this topic mainly from this book, and I have take major understanding from this book about this topic. So these are not just the books that are names written here. These will actually be utilized in your entire course. And this is my normal practice in teaching various courses, that I generally follow 4 to 5 books to make you understand various concepts. So wherever the concept is written good, wherever it has been written to make you understand better, I will try to make that arrangement to make you understand about the concept. So these will be the course contents. For example, this is the chapter number one, structure and growth of electrical power systems. And today's lecture will be basically uh, in today's lecture, we will cover these concepts from structure and growth of electrical power systems. This will be our first lecture. Then in the second lecture, we will discuss about power per unit system and matrix algebra, and also discuss about few fundamental concepts about the electrical network or electrical engineering. Then to make you basically understand or refresh your knowledge for understanding the power system analysis. That's why we'll discuss those basic concepts of electrical engineering, such as complex power, power factor correction, and these are the basic concepts that we will discuss. Complex power, that for understanding the power system analysis, because these concepts will be involved in this course as well. In the third lecture, we will discuss about network matrices, and then we will start about load flow analysis in the third lecture, and we will have a basic understanding of load flow in the third lecture, and network matrix formulations. Then in the fourth lecture, we will start solving Gauss-Seidel method of load flow analysis, and then in the fifth and sixth lecture, we will solve Newton-Raphson method and fast decoupled method of load flow analysis. And in the seventh and eighth lecture, we will try to discuss about the balance fault analysis by applying the fault on the system, and by applying the balance fault on the system. What will happen to the system? What will happen to the voltage and currents and the power of the system? We will discuss in the seventh and eighth lecture of the course. Then after the MITS, we will discuss about the unbalanced fault analysis, unsymmetrical fault analysis 1, unsymmetrical fault analysis 2. Then in from 12th class onwards, we will start studying the power system stability. And then we will have four lectures about power system stability, stability 1, 2, 3, 4. And in the end class, we will discuss about some case studies, and maybe These case studies will be discussed from class to class. It is not necessary that I will dedicate the whole class or the whole one class for this purpose. Maybe I will discuss these practical things in each lecture with respect to the problem, with respect to the concept that we are understanding. I will try to basically connect this concept with the practical implementation or how the electrical industry works in power system or in Pakistan. Maybe I will connect these things in each lecture or with each concept as well. So I have written this thing in a separate form as an industrial practices, but this is not necessary that I will dedicate this industrial practices part to the entire one class of 3 hours. Maybe it will be done, but generally what I done is that I try basically to basically understand to basically discuss these concepts such as PSA context in terms of utilities practices. Utilities, I mean this Islamabad Electric Supply Company, Lahore Electric Supply Company, GEPCO, Gujarat Electric Supply Power Company, and then at a transmission level, we have a transmission network operator, National Transmission and Dispatch Company. So I will also discuss that how power system analysis is adapted by National Transmission and Dispatch Company or a transmission system operator TSO in Pakistan. I will also discuss that how the transmission companies are adopting or basically utilizing power system analysis globally in India, in US, in Europe, and their different practices and what are the standard systems that have been made to basically test your methodologies that you develop for the power system analysis. So this is all about the course and all about the content of the course. Then we have also what about quizzes and assignments? I generally take three quizzes and two assignments. Uh, one complex engineering problem in the lab this time, and before that, the complex engineering problem was involved in theory of this course. So this is generally the case of the assessments, that how assessments are covered. Three quizzes, sometimes four, and two assignments because complex engineering problem was previously taken in the theory part of the course, but maybe this time it will be in the uh, lab part. So this is these will be the assessment mechanism. Then we have, you know, that almost 50% is of for finals and 50% is of your internal. So the internal 50%, for that I think 20% is 30 numbers are for from mates, and the rest of the 20 numbers are from assignments and quizzes. So before again this session 2K19, out of those 20 numbers, before 2K19, out of those 20 numbers that were the part of quizzes and assignments, uh, I basically partition those 20 numbers. I divide those numbers into two parts, and 10 I would give to the. I generally give it to the complex engineering problem, and the rest of the 10 was divided were divided into 5 and 5, and five numbers for assignments and five numbers for quizzes. But this time, because all these 20 numbers have to be maybe because I'm not sure currently, but it is more probability that these 20 numbers will be from assignments and quizzes in the theory part, because maybe the complex engineering will or problem will become the part of the lab this time. So these 20 numbers will come from assignments and quizzes. So the rest of the breakup of the assessment components is simple, because 30 number goes to quiz mids and 50 number goes to finals, and the 20 number is for assignments and quizzes. So this is the course assessment methodology. I have also explained to the different curriculum or the books and the CLOs and PLOs of the course. So I think we should start now the lecture, and I mean this is also part of the lecture, but we should start about our technical content of the course. So students, got it? Have you got my point? What I was discussing with you?
Yes, sir.
Yes, sir.
Yes, sir.
Good. Okay. Uh, have you studied any power systems course up till now? Which power systems courses have you studied up to the current semester? Can
Sir,
anybody tell me?
electrical machines,
Other than that,
electrical network analysis.
network analysis. Okay, this is the basic fundamental course. Any other course related to power systems? Or you are studying in the current semester? Uh, any other course you are studying in the current semester related to the power systems?
Power distribution and utilization.
Yes.
Okay, fine. So don't worry. I will make you understand what actually power system is and why we have to do power system analysis. Now, I hope you can see my screen, the lecture on the your laptops, mobile phones, and computers. Can you see that?
Yes, sir.
Introduction to power system.
Yes, sir.
Fine. Okay. The things. This is actually our lesson summary. That in today's class we will discuss about the course and subject, the role of power system in the society, components of power systems, operation and control, and organizational structure. Uh, this is the course objective, and it is also written on that Word file that I have also shown to you. But you can also read it from here when I will share it with you. So these are again the CLOs of the course, met with PLOs. I will discuss it with you. This is the PLO mapping, and then these are the books, and this is the assessment criteria of the course that again I have already explained to you, but I will share it with you when I will share this lecture with you, this PPT, so you will get it. But this time, again I am repeating this thing. I am not sure about complex engineering problem, but maybe this time the complex engineering problem will go into the lab, and this assignment and quiz thing that is currently 5%, maybe it will become 10% or 15 to 5%. So that can be rationalized as per the decision of the complex engineering problem. But currently, up to this semester, we are following this scheme: 5% assignment, 5% quizzes, 10% this complex engineering problem, which is a major project for the course. Then we have midterm 30% and end term 50%. Now, power system analysis. What is the goal of this course? The goal of this course is to provide an overview of the interconnected power system operation. I will explain to you what is interconnected power system, modern methods of power system analysis and design. The course will equip the student with the basic tools for analyzing the operation of the power system in normal as well as emergency scenarios. So again, I have explained all these topics in the Word file where there I was discussing about the content of the course. Now, what is the power system? This is the first major slide that you have to understand about your system. Now, because you are actually telling me that you have not learned any power system related course up till now, yes, you have actually got a taste about electrical machines, but that was not power system. That was machine, but it is a part of power system, but it is not a power system. But in today's lecture, we will discuss what is power system. Power system is basically uh, the combination of different parts, you can say there. First of all, power system comprises of generating units, generating station, shown with this color red. Power system is comprises of transmission lines, which are shown with this blue towers. Power system is comprises of distribution system, which is shown here with this green color lines. And power system is comprised of load, which is here shown in the form of these industries and these homes. So it means that power system is comprised of generation, transmission, distribution, and load or customer. So when all of these entities come together and join together, connect together or interconnect with each other, we say that we have formulate what? हमने क्या बना लिया? We have formulate what? We have formulate
Power.
power system. So generation is there installed. For example, you generally talk about the Vela Dam, you generally talk about Mangla Dam, you generally talk about Kotatu Power Company, you generally talk about Neelam Jhelum Power Plant, you generally talk about Chichungi Malia Power Plant. You generally talk about various different power plants, and you say that I have seen that generating station, I have gone to that generating station, and that generating station power plant is close to my home, that power plant is away from my home, these wind turbines are installed there. These are all generating stations that are installed everywhere in our country, but these are the generating stations. So generating station is one entity. Then whenever you move from here from UET to Rawalpindi, whenever you move from UET to your home, maybe if it is far flung in the areas, maybe there in South Punjab or something like that in Lahore, in Central Punjab or something like that in Gilgit and Karachi, same like. So whenever you move with the roads and you will see long big towers, and these long big towers of electrical network are known as basically transmission towers, and the lines that are moving on those towers are the transmission lines. So whatever you say, what you will say by looking at those lines, somebody will ask you, sitting beside you in the bus, in the train, in the car, and ask you, what is this? What do you say? What do you say at that time? As an electrical engineer, what is your answer? When you see those long towers, those the big towers, what do you answer them? What you generally say to them? Can you tell me?
Transmission line.
Yes, this is a transmission line. You actually tell them this is a transmission line. Yes, good. So transmission lines are there, they are installed, they are moving, they are basically carrying the power. And what they do is that, what they do, what transmission lines do, they basically transmit power from one place to another place. Fine, agreed. What transmission lines do? What is the purpose of transmission lines? Can anybody tell me?
Transfer
They
electrical power
transfer
from
power.
one place to another.
Yeah, very good. So they transfer power from one place to the another place. So after these transmission lines, when they pass from a big from aside from the motorway, aside from alongside with the railway lines, alongside with the rivers, they basically reach where they reach. They reach near to the big cities. They reach near to the towns. And when they are close to the towns, cities, what happens? Do anybody have seen those long big towers inside the cities as well? Very less, very less. Inside the entire urban areas, you will not see those big towers. Maybe you might say sometimes big towers, but not of that height that you see there alongside on the motorways or on the aside the alongside with the railway lines, along with the rivers, on the mountains. maybe you see towers there inside the urban areas, congested areas, but not of that big size. So, what happens to these basically transmission lines when they reaches close to the cities? What happens? Can anybody tell me?
सर ग्रिड स्टेशन होते हैं वहां पे इनको स्टेप डाउन किया जाता है ताकि
Okay, good. So it means when they reaches near to the cities or the urban areas or the congested places, they basically terminates at the grid stations. And what happens at the grid station? Grid stations basically step down the voltages of these transmission lines and basically distribute that power in the form of small or a lower voltage line to the load ends. And what happens after that? After the grid station, you may have seen if you have noticed in your university what maybe near this Paradise Cafe, you have seen that there are feeders, there are 11 kV lines that are coming, and after that you have a transformer basically installed on a H pole, H type pole, and after that a transformer, the transformer step down again further voltages from 11 kV to 220 volt single phase and 440 volt three phase, and then these three lines that are basically moving like this, three lines moving like this, and they are basically converted to four lines in the form vertical vertically they convert into vertically four lines. So these four lines basically are the secondaries, and they basically distribute power or basically transfer power to the load. So all these basically parts. First of all, generating stations that may be Sardela, Mangla, Ghazi Barotha, Neelam, Jhelum, something like that, Kotaddu, Neelam. Then the transmission lines that are coming from these large generating plants from Tarbela, Mangla, Neelam, Jhelum to the load centers such as Kalasha Kaku, Rawat grid station, and then after that they basically step down the voltages in the form of distribution voltages and form the distribution network, and then this distribution network basically provide power to the load. So these four entities, load, distribution network with the green line, transmission network with the blue line, and these generating station with the red color, when they connect with each other, when they integrated with each other, when they join together, they form what?
power system.
Power
Power
system.
system.
So this is the power system. I will explain this power system in more detail as well. So don't worry about this, that what happens to what. All the questions in your mind will be answered. I have just explained, up till now, I have just explained the four entities, elements of the power system, which is generation, transmission, distribution, and load. And I have also explained this thing that these all four are connected, and after the connection, these four are merged together to form a power system. Individually, they are known as transmission lines, they are known as a distribution line, they are known as generating station, they are known as loads. But when they will connect together, they will form what? They will form power system. So the name of this course says that the name of this course depicts that, demonstrates that this is power system analysis. So what we do in this course is that we will basically perform the analysis of this system. And what this analysis will be? This analysis will be about that how the voltages and currents flow on transmission lines, how these voltages and currents affect the flow in the distribution network, what are the power losses when the power flow on these transmission lines and the entire network, what happens to the network and the generating station, the generator installed at the generating station whenever there will be fault on the lines. You may have noticed that, or you may have learned that, or you may have maybe know that from anybody that there are power outages, there are faults in the system, and due to those faults, the outages occurs. And we will discuss in those course what are the various types of fault that can occur in the power system as well. And what will be the impact of these faults on the system that the customers or the consumers have to face power outages, and what are the values of the voltages, currents at the time of fault, after the fault, during the fault, how we can mitigate those faults, and how we calculate those values of the current, voltages, and power when those faults occur. And moreover, what happened when you transfer power from Tarbela and it reaches close to the cities, and out of the, because just taking an example, if I would take you I would give you an example that, student, what will happen, just consider that water is flowing in river Indus. Just consider water is flowing in river Indus, and take 2 points in the Indus. First point is near the Amir Bhasha Dam of the Indus River, and takes the other point near Sakhar Barrage on the Indus River. So, do we have the same amount of the water, and neglect all the neglect all other water requirements, or the all other water usage in the entire stream from the Amir to Sakhar Barrage? I hope you got my point. What I am saying is that river Indus is flowing from up from that Siachen glacier to the Arabian Sea. This is the overall course of the river Indus. So we are taking 2 points on the river Indus. One is at uh, the Amir Bhasha, where the Bhasha Dam is being made. We have basically taken that point. And we have selected another location on the Indus, that is at Sakhar Viraj. And we are basically ignoring all the water usage uh, in the entire course of this Indus. So, what will be the amount of water that we will get at Bhasha, and what will be the amount of water that we will get at Sakhar? So, will those amount of the waters will be the same? Are those amount of the waters will be the same or different?
No, sir, they will be different.
Of course, different.
Why? Why? What is the reason? Can anybody tell me the reason? Yes, students, can you listen me?
सर क्योंकि जो हमारे पास वाटर फ्लो करता है वो मुख्तलिफ जगह से होके जाता है, उसका उस तरह का फ्लो नहीं रहता जैसा कि डैम पे था
No,
अमीर।
forget about flow. Forget about flow. Uh, I would say that at Bhasha the flow will be more because the river is very congested there. River is very close because it is in the mountainous spot. And as we all go along with the river Indus, the mountains will be mitigated after some time, and the river will be open. The flow will be less. So these all are the natural things. I am just talking about the amount of the water. If I take 2 points, one location at the Amir and the other at Sakhar Viraj, and I am ignoring any other water entry into the river, and I am ignoring any other water utilization from the river. So just consider a tube-like thing, and which in which no other water can enter, and the water cannot leave from the river. So I am just asking you, will the amount of the water will be the same at Bhasha and at Sakhar, or the amount of the water will be different? Just answer me this thing.
सेम होगी सर फिर।
तो अगर हम
See,
सब कुछ नेग्लेक्ट कर रहे हैं तो सब बराबर आएगा ना?
we are not
Same.
neglecting. We are not neglecting everything. We are neglecting only any entrance of the water to this river, because before Sakhar, two other or three other rivers join the Indus as well. So I am actually neglecting that thing as well, and I am also neglecting the water usage from this Indus. I am neglected only two things. One, the water cannot enter into the river from any other source. The water cannot leave the Indus for any other purpose. So I am ignoring only this thing. The other
Same
factors
होगा.
are there. Same होगा? No. It is not possible. It is not. It
सर
will not. How it could be same? Because
सर
see now.
सर पानी की मकदार कम होगी ना सर, क्योंकि वहाँ पर अगर हम वैसे यूटिलाइज नहीं कर रहे मगर उसके अलावा जब नदी में पानी बह रहा है तो वहाँ पर उसे एक जगह से लेकर दूसरी जगह जाने में उसमें पानी तो कम होगा ना.
Due to vaporization.
Why it will be? Yes, one factor. Why good? The other factor, there could be other factor as well. Yes, evaporation is one factor, and what will be the other factor? Absorption by the land as well, na? The land will absorb the water as well. Fine, got it?
Yes, sir. Yes, sir.
So it means that neglect other losses, but consider these as well. The natural things. We cannot ignore them. So the water at Bhasha will be more, and the water at Sakha Biraj will be less because there will be evaporation. There will be losses due to the absorption by the land, by the mountains. So we will not have the same amount of the water there at Sakha Biraj as compared to the Bhasha. So the same thing happens with the transmission lines, that the power that we transfer from generating station to the load ends, the large load centers, generally that power is not same. Naturally, there's power not same because there are losses in the line, and these losses could be due to anything that I will explain, and maybe you will study that in the transmission line courses as well and distribution system course as well. But there are losses, and the power has to face losses because it is a natural phenomena. So therefore we have to basically calculate how much the power is lost in the entire passage from generating station to the distribution station. And the success of any power system engineer is that it basically operates the system in a way that these power losses that happens on the transmission lines, they should remain as much less as possible. Around 7 to 8 years back, in our transmission lines, 4% losses were occurring. 4% losses were occurring in the transmission lines in the entire country. The 4% of the generated power is lost in the transmission lines. And this 4% is how much? This per 4% is this 4% has a such big impact that if we do not lose this power, this 4% power in transmission line, we can lit up or we can energize our whole Balochistan province. I mean to say, the power requirement of current power requirement of whole Balochistan province, the amount of power that consume the Balochistan province, find currently that the power that whole Balochistan province consumed is basically lost in the transmission lines. This 4% is so much big amount. I hope you got my point. Have you got my point?
Yes, sir.
So it means that the losses in the transmission lines are very critical. So if you reduce the losses by only 0.1% or 0.01%, 0.005%, it will have a great impact on the society and on the country as well. So transmission line engineers or the power system engineers are always have a try. They always try to basically reduce these losses to basically safeguard the revenue. Fine. Similarly, we have distribution lines and which are very close to the load centers, and then we have loads. So this is the entire power system. Any question? Any question about the power system? Yes, students. Any question about the power system? Nothing? Okay, fine. So power generation, I will explain the each element in detail now. Power generation. Power generation plants are basically geographically dispersed, located geographically dispersed locations. And I usually teach this course again, power generation, in the 7th semester. And then the power can be generated through various resources such as water, nuclear, solar, chemical, wind, tidal, and hydrocarbons such as oil, coal, natural gas, etc. So in Pakistan, we have water-based power plants that are large dams. Then we have nuclear power plants at Chashma 1, Chashma 2, Chashma 3, and Kanaf at Karachi. We have solar-based power plant at Qadi-Azam, power plant at Bahawalpur. And then the solar power plants are also installed at small levels by various industries, organizations, and even the residential customers as well at about 10 kilowatt level for net metering. Then we have wind power plants for 50 megawatt at Dherki, there in Sindh, Ghotki area, Gharu Keti Bandar. Tidal power plants are not installed in Pakistan, and globally they are in a pilot phase level. So commercially they are not utilized. Tidal farm. Biomass power plants, 2 or 3 biomass power plants are also installed in Pakistan, but more big countries in the world, they largely depend on biomass, and they are producing their lot of power through biomass. Hydrocarbons, most of our power requirements are filled through natural gas, which is both in the form of natural gas and LNG, liquefied natural gas. And we have LNG based and natural gas power plants installed all over in Punjab, such as in Punjab power plant at Jhang. Then we have that Baloki power plant near Phulnagar, Punjab, near Patoki. Then we have other power, the Bheki power plant is Shahura. So these are the big LNG based power plants that are recently installed by the government. Then we have coal based power plant. The big coal based power plant is installed there in Saiwal near Kadepur Canal. Oil based power plants, most large amount of power plants are rely on oil as well, such as Kotaddu Power Company, Muzaffargarh Power Company, Gencos installed at the Hapco. All these big power plants are oil based. So these are the various sources of generation available here in Pakistan, and these are geographically located at a disperse, such as some power plant is located there in Muzaffargarh, some are there in Kotaddu, some are there in Karachi, some are there in Hapco Hub, and some are there in Tarbela, Ghazi Barotha, Neelam Jhelum, and Mangla. Now, then we have Basha, we are considering the Basha. So you see, Chashma 1, 2, Chashma 3, Qaid-e-Azam Bahawalpur, Wend at that Kaharu Keti Bandar. So you see, they are geographically dispersed. They are geographically dispersed. Something is there, something is there, and all around the country. Some power plants are in the north, some power plants in the south. So that's why we say that these are the geographically dispersed. So as they are geographically dispersed, we need to connect them with the main load center. Out of these power plants, that big power plants, have I named any power plant in Lahore? Have I named any power plant in Lahore? Tell me. Have I named any power plant, big power plant located in Lahore? No.
Sir.
Similarly, have I named any power plant located in the Gujranwala? No. Maybe this is a small power plant that is, I think, located at a canal site at Gujranwala, which was famous, that is around 450 megawatt. Nandipur power plant. But sometime it runs, sometime it becomes stop because of the available of the generation resources. So that is located near Gujranwala, but it is again a very small power plant. Then have I named any power plant in Islamabad, Rawalpindi? No. So it means these power plants are located at geographically dispersed location. So if a power plant is located in Tarbela, but the power requirement or the load or the main load is available in the Kalashagaku, Gujranwala, Veerabad, Sialkot, because this is a big load in a system. The most of the Pakistan load is located from start from Gujarat and end up to almost Phulnagar or Pattogi. So this is the basic load center of our country. The 60 to 65% of the load is basically available.
दरवाजे को बाहर से कुंडी लगाए
60 to 60 to 65% of the load of the country is available in this small part of the country, from right here from Gujarat up to the this Lahore and to the up to the this arrivant site. So this is the small area where around 60% of the load of the country is available. So your power plants are located at Kotaddu, power plant is located at Kanna, power plant is located at Bhavalpur, power plant is at Sahiba, power plant is located at Tarbela, power plant is located at Mangla. So you need to basically carry or transfer that power from Tarbela to Islamabad, Tarbela to Gatti, Gatti I mean Faisalabad, Tarbela to Kala Shagaku, Tarbela to New Lahore, Tarbela to Kot Lakpat, Tarbela to Mardan, so Mangla to Gujranwala, Mangla to Gakhar Mandi, Mangla to Kharia, Mangla to Mangla to Jalalpur Jatta, Mangla to Dina. So you have to transfer this power to these big grid stations that I have basically discussed it with you. So how we can transfer this power? We have to use what? We have to use transmission lines. So transmission network carry this power that is generated in those genetic station and transfer that power to the big load centers. So this is the breakdown of the power that we produce from various sources such as furnace oil, hydropower is 27%, LNG, natural gas and coal and renewables. You can basically see that slide when I will share these slides with you. So the power installed in these power plants, that is shown to you, these power plants. So power installed there is transferred through the load centers such as New Lahore 500 kilovolt, Rawat 500 kilovolt for Islamabad Rawalpindi, Gatti 500 kilovolt for Faisalabad, similarly Nokhar 500 kilovolt grid station for Gujranwala, similarly 500 kilovolt Khanewal for Multan, 500 kilovolt Hyderabad for Hyderabad, and these for 500 kilovolt Mardan, New Mardan for Mardan and Peshawar. So the power is transferred to these large or high voltage grid station through a high voltage transmission line, the large transmission line. And why we use high voltage? These transmission lines, first of all, you must know that the transmission lines are basically we have transmission network is basically divided into two parts. One is a transmission network, and the other one is known as the sub-transmission network. One is known as the transmission network, and the other one is known as the sub-transmission network. Got it? Please listen it carefully.
Yes.
We have we have two transmission voltages in Pakistan and one sub-transmission voltage. Write it down anywhere, because when I take the Viva or somebody will take the Viva from you, you will get confused. There are two transmission voltages in Pakistan, primary transmission voltages in Pakistan. One is 220 kilovolt, 220,000 volts. It means 220 kilovolt. And the other one is 500,000 volts or 500 kilovolt. This is the primary transmission network of our country. Then we have a sub-transmission network, and the voltage level of sub-transmission network is 132,000 volts. I mean 132 kilovolt. So primary transmission network has voltage levels of 220 kilovolt and 500 kilovolt, and sub-transmission network has voltage levels of 132 kilovolt or 132,000 volts. Fine. So, what is the purpose of these transmission networks? Connect generating plant to consumption point, interconnect power pool, reduce generation reserve, and cost increase reliability. Then we have transmission. There are two types of these are the primary and sub transmission are the transmission network disintegrated based on the voltage levels, but there are two transmission types as well. One is AC transmission, in which we will use alternating current for the transmission of power, and the other transmission type is DC transmission, in which you use direct current from the transmission of the power. So largely the transmission network in the world and in the Pakistan as well is AC transmission. But recently a DC transmission line is installed in Pakistan, and currently it is operational as well. And that DC line is from Mutiari to Lahore. Mutiari is there in Sindh, and Lahore, you are well aware of Lahore. So Mutiari to Lahore, from Sindh to Lahore, we have recently installed a DC transmission line, and the voltage level of this DC transmission line is 660 kilovolt plus minus HVDC. The voltage level of high voltage DC transmission line in Pakistan is 660 kilovolt, 660 kilovolt. And the voltage level of AC transmission line is, what are the voltage level of AC transmission lines that I have already tell you? Please tell me.
500 kV
500.
or 220 kV.
500 kilovolt, or then
220 kV.
220 kilovolt.
these are the primary transmission lines. Fine. And what about secondary transmission?
132 kV.
132 kilowatt.
132 kilowatt. Very good. So be always vigilant and remember these voltage levels for the transmission network. Now there are two transmission types: alternating current transmission, and the DC transmission. Largely in the world, mostly at the global level in Pakistan as well, AC transmission is performed. But somewhere at some point, based on our requirement, we also install DC transmission line. So why we prefer AC over DC? So this is a small graph which actually explain to you that why AC is preferred over DC for transmission of electrical power, because DC lines are expensive. First point is that the DC lines are expensive as compared to AC lines. So DC lines, DC lines are, see here, this is the cost and here is the transmission distance. So see, the AC transmission is currently here in this graph. If you will follow my cursor, in this area from here to here, the AC transmission is economical as compared to DC. See, and DC, the cost of DC transmission is high as compared to AC. But when we reach at this point, after this point, the cost of AC will become more and the cost of DC will be less. And can you basically point out what is this point? This is basically the distance. It means after what distance? After some distance, the AC will start becoming expensive and the DC will start becoming economical as compared to each other. So what is that distance point? That is around 800 kilometers. If we have 800 kilometers of overhead line, that is generally you visualize around whenever you move alongside roads and railway lines. So those overhead lines, when you installed an overhead line longer than 800 kilometers, then we will have a choice that we should install a DC transmission line because it will be more economical as compared to it. But if we have to install a line lesser than 800 kilometers of a distance, then what will be preferable? Then AC lines are preferable. So this is the chart. And for underground lines, because transmission is done underground as well, but there are less transmission lines, very less, few transmission lines in the world that are basically done under the ground. So these few projects are basically installed in Europe uh, because these are the submarine lines, submarine transmission, because one European country is transferring power to the another European country through sea or something like river. So for that purpose, under the sea or in the water, you see that in overhead lines, the distance when DC line become economical as compared to the AC line is around 800 kilometers. But for submarine cables, submarine transmission lines, yani I mean to say that for under the sea transmission, you have an idea about under the sea or submarine internet cable? Do you know about that? That internet that we are using here in Pakistan, that cable is basically coming as a submarine cable under the oceans and under the seas from UK and USA. You know about that or not? Do you have an idea about that or not?
Yes, sir.
Yes, sir.
Similarly, on the same concept, the power is also transferred to the other countries as a submarine in the submarine cables. For example, if Pakistan wants to transfer the power to this uh, which country that we can see from Gwadar, I think Bahrain or Yemen. No, it's not Yemen, which is very close to the Gwadar. I think it's Bahrain, something like that.
Oman.
Oman, yes, you're
Oman.
right. Oman. So if we want to basically transfer power to the Oman, what we have to do is that we can't install overhead lines because what is in between us and Oman? Sea. So
See.
it is difficult to install these large transmission towers there. So we have an option that we can transmit that power as a submarine cable. So people actually do it. Countries around the world basically use this concept to transfer power from one country to another. So for submarine transmission cables, 50 kilometer is the distance. That if we want to transmit power under the sea, uh, then if we have a line lesser than 50 kilometer, then AC will be viable. And if we have a distance greater than for transferring the power greater than 50 kilometer, then DC line will be the better choice. So this is the comparison with AC and DC. There are other comparisons as well that we will discuss in a transmission line course in the 7th semester. But for your power system analysis purpose, I think this knowledge is enough for you because we have to basically study power system analysis and not the transmission lines. Therefore, I have to stop here in discussing about the transmission line. So
सर
high voltage, yes.
सर एक क्वेश्चन है सर
Yes, sure.
सर क्या ऐसा नहीं हो सकता कि हम शुरू में एसी लाइन यूज करें और फिर आगे उसको डीसी में कन्वर्ट कर लें
Yes, why not? You can do it, but it all depends again on the your requirements. It all depends on your requirements. You can do it, but if you're transferring the power in the form of AC, and now if you're converting to DC, then it will involve some cost. So yes, people do this thing. For example, once, maybe you remember or not, uh, basically the trains basically run from Lahore to Khanewal, the sector in Pakistan. Once these were the electric trains. The engine was electric engines, and they basically use electrical towers for the electrical towers were installed by railways there, and they use basically that electricity, and the engine run on that electricity and take passengers and big trains from Lahore to Khanewal, and after that the engine changes and again they convert it to the diesel engine and something like that, and they took the train to the Karachi. But those lines were DC lines. That engine that basically run from Lahore to Khanewal and take their 10, 15, 25 coaches with that on the back of the engine, that engine was running on the DC. So depending upon our requirement, because at that time we require DC lines. So first of all, what we do is that we basically took these transmission lines in the form of AC to the near to the as grid station of the railway, and then converted to the DC lines, and then to use that DC purpose for our purpose. So yes, it is possible, but naturally, generally, this is not favorable. This is not this is not done. Why this is not done? Why? Because conversion from AC to DC involves cost. Conversion from AC to DC involves cost. Because how we convert from AC to DC? We need what? Can anybody tell me how we can convert AC to DC? We have AC power. We want to convert it into a DC. What we have to do?
So rectified.
Yes, we have to use rectifier. We have to use rectifier. And the rectifier that you have studied is a simple diode rectifier in electrical network course. But those diodes are very low voltage and they have very low power capacity. So it means we have to install such diodes, such resistors that have such high power capacity that can sustain such high currents. So diodes can't do it. There are devices that do it, but those are very expensive, and you will study them in the power electronics course. And those devices basically form converters, and those converters are known as AD to DC converter, DC to AC converter, AC converter, DC DC converter, and they basically use what they would basically do. What is that? They basically transform AC to DC, DC to AC, AC to AC with different voltage level, DC to DC with different voltage level. So they are very expensive devices and at such high level of voltage. So they involve huge cost. That's why DC transmission is expensive as compared to AC transmission, because it involves converter, power electronic converters. So I hope you got my point. I hope you got my point.
सर एक
Yes.
क्वेश्चन सर
Yes.
सर जो ट्रांसमिशन लाइंस होती हैं सर हम उनमें कैसे डिफर कर सकते हैं कि ये 500 केवी की है या 220 केवी की है
Yes, by looking at the transmission line, you can easily figure it out that this is a 5000 as 500 kV transmission line. This is a 220 kilovolt transmission line. By just simple looking at that line.
Excuse me, sir.
Yes.
Sir, I have a question. अगर सर हम लोगों ने फ्यूचर में कभी पावर ट्रांसमिट करनी है किसी और कंट्री से और वहाँ पे ट्रांसमिशन वोल्टेज जो है वो चेंज है एज़ कम्पेयर टू पाकिस्तान, फॉर एग्जांपल पाकिस्तान में है 500 केवी प्राइमरी और 220 केवी, इंडिया में है 765 केवी, तो हम इस डिफरेंस के साथ ट्रांसमिट कर सकते हैं?
See, we can transmit the voltage, but we want to utilize it, we have to convert it to our voltage levels. For example, from India, we can take the power in the form of 765 kilovolt. That line will come. Nobody will stop those line. The dogs running under the line, they will not stop that line. The soldiers protecting the borders under the line, they will not stop the line. The line will take the power. The line will take the power, transfer the power. The line will take on carry on the power from one point to another. But as soon as they will reach any grid station of 500 kilovolt, then we have, because in our 500 kilovolt grid stations, we have installed the transformer with the primary side of what? 500 kilovolt, and their secondary side is 220 kilovolt. What we do at 500 kilovolt grid station? I just want to explain this thing to you. See, we have take an example of 500 kV grid station. The 500 kV grid station for Islamabad Rawalpindi is installed in Rabat. Maybe you have gone there, maybe you have passed in front of that grid station that is installed at the main GT road after passing the Rawat city. The 500 grid station of Gujranwala is installed at Nukhar near Laddewal Vadai. The 500 kilovolt station of Lahore is installed at New Lahore after Thokar, because there are two 500 kilovolt stations in Lahore. The 500 kilovolt station of Faisalabad is installed in Gatti. So what we do at 500 kilovolts, when we say that this grid station is a 500 kilovolt grid station, what we do basically at that 500 volt grid station is that we basically step down the voltage from 500 kilovolt to 220 kilovolt or any other utilizable voltage that we need at that point. That is the basic purpose of 500 kilovolt grid station. Got my point or not? So at Rawat grid station, the lines that enters the Rawat grid station, from where they are coming? The lines that enters the Rawat grid station, from where they are coming? Can anybody tell me? They are coming
Generating
from,
units, sir.
yes, they are coming from generating stations, from Tabela, from Neelam Jailam, from Mangla, anywhere from big generating station, from generating station, and they have the voltage level of, 500 kilovolts. They have the voltage level of 500, because this is a 500 kV grid. And what is the purpose of this 500 kV grid station? This 500 kilovolt grid station basically step down the voltage from 500 kilovolt to what? To 220 kilovolt or any other required utilizable voltage at that grid station or near to that grid station. It is not necessary that, it is not necessary or compulsory that that 500 kilovolt grid station will only step down the voltage to 20 kilovolt grid station. Yes, it can step down the voltage to other voltage level as well, but the primary purpose of that grid station is to basically step down the voltage from 500 kilovolt to 220 kilovolt. Now this 220 kilovolt line will
Sir,
now this 220 kilovolt line will move on from Rawat grid station. It will be it will get out from the Rawat grid station, and where it will go after passing out or after coming out of the Rawat grid station. These 220 kilovolt transmission lines will go in the 220 kilovolt grid station. And where these 220 kilovolt grid stations are installed? In Islamabad, Rawalpindi, I can give you an example. One 220 kilovolt grid station is installed in Qaid-e-Azam University. Besides Qaid-e-Azam University, one 220 kilovolt is installed there. The other 220 kilovolt grid station is installed here in Sangjani. The Sangjani Tool Plaza, daily you cross Sangjani Tool Plaza for the tool purpose. But if you look at the left side of that tool plaza near Sangjani stop, you will find out a grid station, and that grid station is a 220 kilovolt grid station. Then where is another 220 kilovolt grid station here in Pindi, Islamabad? That is at near this Hasanabad. So we have almost 3 to 4 220 kilovolt grid station in Islamabad, Rawalpindi. From that 500 kilovolt grid station, that the line that is outgoing from that 500, that is of 220 kilovolt. That 220 kilovolt line now will enter into Qaid-e-Azam University grid station, in Sanjani grid station, at the voltage level of 220 kilovolt. And now this 220 kilovolt grid station will step down the voltage from 220 kilovolt to 132 kilovolt. So this is the basic purpose of 220 kilovolt grid station, that it will step down the voltage from 220 kilovolt of voltage levels to 132 kilovolt of voltage level or any other voltage level that is required for the utilization of the voltage in the nearby spaces. Fine, got my point? Now this 132
Yes, sir.
kilovolt line, now these 132 kilovolt line terminating or going out of that 220 kilovolt grid station, these 132 kilovolt line will now come near to our homes. Where near to our homes? Maybe you have seen a grid station there in HMC. Maybe you have seen a grid station there in HIT. Maybe you have seen a grid station at near Pindi Stadium alongside that food street. Maybe you have seen a grid station alongside with Koinur factory on this Peshawar road. Maybe you have seen a grid station there in Pindi Kent. there are various grid stations near your houses and near your living spaces. Those are basically 132 kilovolt grid station. The line that enters to those grid station is of voltage level 132 kilovolt, and the transformers installed in those grid stations basically step down the transmission voltages of 132 kilovolt to 11 kilovolt. So the line that will go out of the 132 kilovolt grid station, the voltage level of that line is basically 11 kilovolt. Now these 11 kilovolt lines in the form of feeders, this placed horizontally, they move. Maybe you can see my hand, fingers. These 1100, these 11 kV lines in the form of horizontal shape, they move along our roads, our street side, and they basically move out of the streets on the small roads, the roads that are close to our homes, the main roads. And then what we do is that we install transformers on these lines and step down this 11 kilovolt to 220 kilovolt or 440 volt three phase. And then those countries in the form of vertical four lines, they enters into our streets, and from those four lines we generally take one neutral and one phase, and then take a service main line and connect that to our meters. So what happens? 500 kilovolt grid section step down the voltage of electrical power from 500 to 220. 220 volt grid section step down the voltage from 220 to 132 kilovolt. 132 kilovolt grid section step down the voltage from 132 to 11 kilovolt. 11 kilovolt lines run into our roads, into streets, and then what happens? Then we install a H-type poles, and out then H-type poles we install transformer that you can see in your university near Paradise Cafe and near that thermodynamics lab, and so anywhere in university you can find out the transformers installed. These are basically 11 kilovolt to 220 or 440 volt transformer. At their primary side we have 11 kilovolt, and on their secondary side we have 220 volt single line to ground and 440 volt line to line voltages. So these transformers you can find anywhere in your industry, and these are known as the distribution transformers. And all other transformer from generation to your distribution, and all other transformers are known as power transformers. And the transformer that you can see all around you, near in your university, around your homes, installed on the poles, on the H-type poles, placed on the platform in the CDA sectors, barrier town, defense, DHA. All these transformers in the green color or in the dark gray color or the black color, all these transformers are known as distribution transformers, and their voltage level is 11 kilovolt to 440 volt three phase. Now your question.
सर क्वेश्चन ये था कि सर हमारे पास जो पाकिस्तान में सर अभी जो बताया कि हमारे पास इंडिया में 765 किलो वोल्ट की सर पावर ट्रांसमिशन हो रही है। सर पाकिस्तान में हमने स्टैंडर्डाइज 500 किलो वोल्ट किया हुआ है, तो सर हम 500 से ज़्यादा भी कर सकते हैं, उससे कम भी कर सकते हैं, हमने 500 ही क्यों स्टैंडर्डाइज किया हुआ है प्राइमरी को?
See, there are standards adopted in the world as well. Fine. So the value, the voltage level depends upon the distance. As India is a large country, India has long distances. So as the distance increases, the voltage level also have to increase. So because India has long transmission lines as compared to Pakistan, so they have to increase the voltage level. First of all, this thing. Secondly, why 500? Why not 440? Why not 495? Why not 350? Why not 550? Why not 600? Why? Because these are the standard operating voltage levels that are being basically decided by the global unions, IEEE, and global societies. Why? Because see, there must be some standard. There must be some standard to which the countries or the people they work. Because if there will not be any standard, you have to basically then each and every person has to manufacture or design his own system or her own system. Now from where you can take a transformer of primary with 450 volt, 450 kilovolt, and a secondary of something like 270 kilovolt. You will not, it will not be available in the market. If it will not be available, you will manufacture your own transformer. If you have the capacity, you can, but you will manufacture one transformer. You will manufacture 10 transformer. Will that be a viable solution, an economically viable solution? Will you achieve a break-even point by installing a unit and making 10 transformer of your required voltage? So there should be some parameter, there should be some standard to which different countries and to which different people should basically opt, because you have to manufacture the equipment, you have to train the manpower, you have to basically make different people understand what happens and what is there. So these are the various things that people are adopting. Again, why 500 becomes standard or why 220 becomes standard? Basically, why 500 becomes standard? Generally, the voltages or the voltage levels were adopted in the multiples of 11. For example, 11 kV, 22 kV. Before previously, these were the voltage levels that were adopted. 11 kV for transmission. Currently, it is used for distribution, but distribution then was 66 kilovolt, 33 kilovolt, then up to that 220 kilovolt. So these are all the multiples of 11 or close to 11. So, but when they find out that if you have certain distance and you transmit power on this voltage level, it will become most optimal and it will have more lesser power losses. So for different level of distances, the world electrical power societies have decided that for if you have this amount of distance, you will use this voltage level. If you have this amount of distance, you will use this voltage level, then your losses will be less. You can use other voltage level as well, but I mean other mean for example, for a certain line, 220 kilovolt is preferable, but you want, no, I will not use 220 kilo, I will use 500 kilovolt. You can use 500, but it will become a costlier solution, because you can do something, you can take the passenger in a highest and you are basically reserving a bus for that. Why you are doing it? Because bus will consume more fuel, bus will be less comfortable, bus will have more tool cost. So why, if somebody, if some students can be taken on the highest, why are you using bus for doing that? And similarly, if you have a passenger of a big bus and you are saying that I will manage that in the coaster, yes, maybe they can go into a coaster, but they will be uncomfortable when you will reach your destination. Somebody's hair will be going somewhere, somebody's shirts will be going somewhere. So there should be some optimum selection of your vehicle. Similarly, there should be some optimal selection of a line. So if you take that much of power, if you have to basically, if you have that much of distance, then this is the voltage level and this is the transmission line that you should use. These are the standards that have been made. And now there should be some standard, therefore they have decided 220, 500, 765, 660, 1000 DC. So there are the standards. So this is the thing, because these on the, once what happened, India has made a mistake. I can here give you an example. The world was actually working on 220 kilovolt, 500 kilovolt, 765 kilovolt, 760 kilovolt. And what India has done in late 1980s, when they basically transformed their transmission network to a modern transmission network and a big transmission network, they opted for 400 kilovolt. 400 kilovolt. So India has, yes, 765 kV transmission lines, but they have two or three 760 kV transmission line. Most of their network is 400 kilovolt. And the 400 kilovolt network is, I don't know, maybe in any one or two any other countries in the world located there. Otherwise, only India is the country in the entire world which has basically made 400 kilovolt network. And everybody gets turned what they have done. Basically, they have made a mistake by selecting a 400 kilovolt network. So India entire network is on 400 kilovolt. That is not 760. They have, yes, just like Pakistan. Pakistan has 660 kilovolt DC line, one DC line. Similarly, they have one or two 764, 765 kilovolt line. So we can't say that India has a 765 kilovolt system. So India has 400 kilovolt high voltage system, but yes, they have two or three lines which are of 765 kilovolt AC. Now they have committed a mistake by selecting a 400 kilovolt. We haven't committed a mistake. We have decided as a right selection that 500 kilovolt. It was adopted in the world, as it was adopted in the world. When we go to the ABB, when we go to the Siemens, when we go to the PAL, when we go to the Schneider, Schlumberger, all these companies have an equipment. When we ask them, we need this transformer, they say, oh, okay, they take this transformer. This is a 500 kilovolt transformer. Well, you can take that and ship it and have use it there at the location. But what happens to India? When they asked for 400 kilovolt transformer in the entire world, nobody was manufacturing that transformer at that time. Why? Because 400 was not a standard. Got my point or not?
Yes.
Yes, sir. You got my
Yes, sir.
point.
Got the point.
Now, what
Yes.
happened? No, what they have done? No, this is not the end of the story. This is not the end of the story. This is basically, you can say that a middle part of the story. Now, what they have now they stuck now. Indians get stuck at that point. Now, what they have done is that they now at that time start making their own transformers because they have no other solution. They have started making their own transformer. They were in the initial phases in the initial phases of the transformer manufacturing. It has a lot of losses. It has a lot of problems. But they try to make it more and more convenient. They try to make it more and more better. Over the years, they work on that transformer. With the passage of time, they basically developed an efficient transformer. Maybe of not that efficiency that Siemens is manufacturing, maybe not of that efficiency that Climax or ABB is manufacturing, but they have developed their own transformer. And we took that transformer from Siemens or ABB from up to last 2 or 3 years. So, and they have developed their own transformer. They use their own transformer. Yes, it has initially a lot of losses. They initially that have lot of problems. But over the years, that have managed to make it better. And now they have developed their own transformers, their own 400 kilovolt transformer. And when any other country in the world installed 400 kilovolt transmission line, they basically taken transformers from India. So, got one point, my students. I hope you got the point. So this is the difficulty of basically not choosing or selecting a standardized voltage or power levels for transferring the power. Yes, got my point or not?
Yes, sir. Got the point.
Okay, good. So this is why we done high voltage and high voltage on high voltage transmission offers. What are the benefits of high voltage? Why we use high voltages for? Sorry, just 1 minute. Just 1 minute. अच्छा जस्ट 1 मिनट साथ मेरी क्लास हो रही है मैं 1 मिनट आपसे बात करता हूँ साथ जस्ट अ मिनट So now what are the advantages offered by why high voltage? Why not low voltage? Why high voltage? High voltage transmission offers you long transmission losses. Lower your losses will become less. Why losses will become less? Because we have high voltage. You know that power is equal to P is equal to VI. And if we want to transmit the same amount of power, fix the value of P and increase the voltage, then what we have to do? We have to reduce the, or what will be reduced? We have to reduce the value of the current. So
Current.
if the voltage is high, if we will increase the voltage, automatically the current will reduce. And if the current will reduce, then P is equal to I square R losses will reduce. So therefore, if P is equal to I square R losses, P is equal to I square R means power loss. This is a power loss equation. P is equal to I square R. So if and I square R losses will decrease. If voltage will increase because V is increasing, I is decreasing. If I decrease, then the square of I will be less. However, if I is increasing, if we take if for example take the value of I is equal to 4. If I is increasing, the square of 4 is 16. I square R, the square. We have to take it as in the formula. We have to take the square of the 4. So the square of the 4 is 16. So if the current will increase in the line, then for example, before that it was 4, now it is 5. The square of 5 is equal to 25. So it means the current here increases 1 ampere, but in the formula, the losses will increase from 16 to 25. But if the value of the current decreases in the line and the value of the voltage, because the voltage increases, the current will automatically decrease. If the value of the current decreases from 4 to 3 or 2, the current will reduce from 16 to 9 to 4. So see how the power loss will decrease if we will increase the value of the voltage. So therefore we increase the value of the voltage. We use high voltage transmission lines because we want there should be less amount of the current that should flow from the lines. सेकेंडली लोअर लाइन वोल्टेज ड्रॉप पर किलोमीटर अगेन आपके वोल्टेज ड्रॉप भी कम होते हैं रिड्यूस राइट ऑफ वे रिक्वायरमेंट रिड्यूस राइट ऑफ वे रिक्वायरमेंट मींस सी you may have noticed that the lines passing from various areas around where you move on the motorways again on the railway lines. So from where the line passes, it takes some space. Fine, got my point or not? From wherever the transmission lines pass, they took some space. So for that space, you have to install. How they take space? You have to install tower. How they take space? You have to install the lines. The lines are basically spreaded like this with their arms. So they take some space. It means for installation of any transmission line, you need space. You need space. And that space is basically, you have to basically install towers. You have to install towers on the land, and that land belongs to some person. And maybe that person is reluctant to install the tower on their land. So it becomes a problem. Secondly, when you are passing transmission line from somewhere, for example, near the railway lines, the railway department will come and they will say to you, don't pass line near our railway line because it will be dangerous for the uh, rail or it will be dangerous for something or equipment or something like that. So they will not allow you pass the line over the railway line. When you will start passing the line over the motorway people will come and they will say, no, 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 don't pass the line over the motorway. Then if you will try to pass the line near any urban area, near any airport, they will not allow to pass the line near the airports. If you want to pass line from any land, some people will come, they will say, no, 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 don't install towers on our land. We are using it on our own purpose. No. If you will try to install in any urban area, the people will come, oh, no, 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 don't install a tower near our home. So it will become a great problem for a transmission engineer or for power system engineer to basically install a tower because people will not allow you. They will go to the court, they will take the stay, and you will be stopped there. So this is a big issue. So what I mean is that when you want to install a transmission line, you need to have a right of way. So if you will install a high voltage transmission line, you have to install less amount of lines. And if you will install low voltage transmission lines, then you may have to increase the number of lines. to transfer the power from one place to the another. So by utilizing a high voltage, the number of transmission lines will decrease. Lower capital and operating costs. If you will use high voltage, the line will become more and more economical. So power transmission equipment. In power transmission, we use various equipments, and I have basically pasted their pictures here as well in my lecture. See, this is known as a power transformer. Fine. Its purpose is to basically step down the voltages and step up the voltages as well. Add generating station. The transformers, this type of transformer, they are used for stepping up the voltages. The generating voltages are generally from 6.6 kilovolt or 3.3 kilovolt to 25 kilovolts. They are very much less. And transmission voltages are around 220 kilovolts and 500 kilovolts. So at generating station, we need a step-up transformer for stepping up the voltage from 9.3 kilovolt, 11.8 kilovolt, 18 kilovolt, 22 kilovolt to 220 kilovolt or 500 kilovolt. So there at the generating station, the power transformers are used to step up the voltages, and at grid stations, they are used for stepping down the voltages from 500 to 220, 220 to 130, 132 to 11, and 11 to 220. This is the distribution transformer. See, this is the distribution transformer.
सर आपकी स्लाइड नेक्स्ट शो नहीं हो रही, प्रीवियस शो हो रही है, अब हो गई है शो.
Can you see it now?
Yes sir.
So I was discussing about this is the power transformer. Distribution transformers are available in different shapes around the world. These are the three single-phase transformers connected together to form a distribution three-phase transformer. But in Pakistan, you will rarely find out this type of distribution transformer. You will find out a transformer that are being installed at your university. These are the voltage regulators and phase shifters. And why voltage regulators and phase shifters are used? Phase shifters are used basically is to shift the phase from one side to the another, and voltage regulators are used basically to regulate the voltage. So this is the equipment. This equipment is also installed at the grid station. Now, transmission lines and cables, or the other equipment that we know, we need power transmission lines and cables. Circuit breaker and isolators. These are the isolators. These are the isolators. And these are the circuit breakers that are installed at substations again at our grid station. Shunt and series reactors and capacitors. Then we have lightning arresters. These are the lightning arresters. These are the lightning arresters. Protective relaying equipment that is installed in the room at grid stations. Fact devices against STATCOMs and static overcompensated SSCs. Converters and inverters. And this is a damper, and this is basically used to basically stop any vibration in the transmission line. You may have seen those dampers placed on the transmission lines when you will see long transmission lines anywhere around you. Now, standard transmission voltages in Pakistan are 500 kilovolt, 220 kilovolt, 3132 and 61. And this is the transmission line for 500 kilovolt. This is the transmission line 500 kilovolt. And this is the transmission line for 220 kilovolt. This is the transmission line for 132 kilovolt. And this is the transmission line for 66 kilovolt. And this is the transmission line. This you can see there. This transmission line. This is our DC transmission line. 660 kilovolt DC. Now distribution system equipment. Distribution transformer. This is the distribution transformer. And these are the feeders that I was explaining with the help of my fingers. This horizontal line, these three horizontal lines. This is known as feeder or primary distribution. Is also known as primary distributor. Primary distributor, or in Wabda language, it is known as feeder. These are the cutout cutons. Maybe you have seen upside of your transformers installed on the H type. Have you seen this thing? Have you seen this thing? Most of you have seen this thing. This is basically a fuse. This is also known as cutout cuton. Have you seen this or not? Yes, you
Sir.
must have seen. You must have seen this. These are the lighting arresters placed on the distribution transformers, and generally in Pakistan they are not placed, but globally they are usually placed. These lighting arresters with the distribution transformers. This is the protecting relaying equipment. This is the protective relay. Recently, digital and micro computer-based relays are installed in the distribution stations. These computer-based relays can can perform all the functions of under frequency, over frequency, under voltage, over voltage relaying purposes. Before that, these computer relays, different types of relays are installed. I mean to say, for over frequency, you have to install over frequency relays. For under frequency, you have to install under frequency and under frequency relaying phenomena. But after the arrival of this computer-based relaying system, all the relaying processes, either it is due to over voltage, either it is due to under voltage, either it is due to over frequency, either it is due to under frequency, all these relaying phenomena are basically performed through this computer based relay, because it is computer based. And I will explain you when we will discuss about the fault, that how this computer based relay know that this is a problem, this is over voltage, this is under voltage, which phase I have to trip out of these three phases, which fault it has occurred, and which feeder I have to trip. So this is an intelligent relaying system, and I will explain to you this thing in chapter number 10 when we will discuss about that. Now, key operational goals of a power system is that when you are sitting in a national power control center in there in H8 Islamabad, or sitting as an SDO operations or SDO maintenance there in NTDC or any distribution company, your main goal is that your generation should be equal to your demand and losses. That whatever the loss that is occurring in the system, either through technical or either through theft, and the demand by the customers, the loss and the demand should be, the summation of the loss and demand should be equal to the generation. I mean to say that the generation should be equal to the available generation should be equal to the demand and the losses of the systems. And system security equipment power flow must not. Secondly, जो आपका पावर फ्लो है सिस्टम के ऊपर, वो एक्सीड ना करे अपनी जो रेटिंग्स है, इक्विपमेंट की जो रेटिंग्स हैं उससे ज़्यादा एक्सीड ना करें, और पावर बैलेंस शुड बी मेंटेन। अच्छा, फिर पावर क्वालिटी कंसंट्रेशन क्या है कि आपकी जो सिस्टम की फ्रीक्वेंसी है पावर सिस्टम के अंदर, फ्रीक्वेंसी की क्या है कि जनरली वी से दैट आवर फ्रीक्वेंसी, पावर फ्रीक्वेंसी इन आवर पाकिस्तान इज, व्हाट फ्रीक्वेंसी डू वी हैव, विल टेल मी?
50 kilo, 50.
Yes, 50 hertz, no? 50 hertz. So the constraint here is that the frequency should not be less than 49.5 hertz and it should not be greater than 50.5 hertz. Fine. Similarly, the voltage in per unit for uh, high voltage system in per unit should not be lesser than 0.95 per unit and should not be greater than 1.05 per unit. What does this actually mean is that in higher voltage transmission network, it means that you have 5% of voltage flexibility. And what does this actually 5% means? It means that your voltage should not exceed more than 525 kilovolt in 500 kilovolt transmission line, and your voltage should not be less than 575 kilovolt in your 500 kilovolt line. Fine. Similarly, in your 220 kilovolt line, your voltage should not exceed more than 230 kilovolt, and your voltage should not be less than 210 kilovolt in a high voltage line. This actually 0.9 to 1.05, this is in per unit, which means that it should not be less than 5%, it should not be increased by 5%. However, in distribution networks such as this 220 kilovolt network that is installed near our home, we have 10% of operational constraint. That means that our voltage should not exceed from 240 kilovolt. If it is a 220 volt system, then our voltage should not be more than 240 volts, and it should not be less than 200 volts. So this is for distribution network, the voltage flexibility. I hope you remember these frequency and voltage regulation constraints. Power utility structure, we have two types of utility structures that is adopted globally and here in Pakistan as well. One utility structure was traditional, and the upcoming or the current utility structure is known as restructured or deregulated power utility structure. Now, what is the difference between traditional utility structure and what is the utility? First of all, you must know. Utility is the company or organization that basically is responsible for providing the power to the consumer. Utility is an organization or entity that is responsible for generating, transmission, distribution, and basically transferring the power to the consumer. So, traditional utilities. What are the traditional utilities? It means that the utility or the company or the organization that is transferring the power to the customer, that has a traditional structure. That has a traditional structure. Now, what does a traditional structure means? Traditional structure means, students, in traditionally the generation, the transmission, the distribution, all these three elements are the entities of a power system were owned and operated by same owner or same regulator. Got my point or not? I mean to say, the generation is done by WAPDA, the transmission is done by WAPDA, the distribution is done by WAPDA. This is an example of traditional utility, that the same utility generates the power, the same utility transmits the power, and the same utility distributes the power to the consumer. So this is a traditional style of power transmission transferring to the consumer, and this is the traditional style of a utility. So in Pakistan, up till 99 2000, we have followed the traditional utility structure. Therefore, even today, when there comes any issue with the power at your home, your father or you will say that this problem has been created by WAPDA people. The WAPDA is responsible for that. I will go to the WAPDA office. I will collect my bill from the WAPDA office. He is serving in the WAPDA. You will see these things. However, if you see it realistically, currently that person or the person that you are talking about or the problem that you are talking about, that is not related to the WAPDA. That is related to if you are living in Islamabad, Rawalpindi, up to Khariyan, here in Texlava, you have, or your problem is not with WAPDA, your problem is with Islamabad Electric Supply Company. I hope you got my point, what I am saying. So up till 99, all these purposes, transmission was done by WAPDA, distribution was done by WAPDA, generation was done by WAPDA. But in 99 2000, the government of Pakistan at that time decided to basically restructure the electrical industry in Pakistan. And they have decided that as our electrical infrastructure is growing day by day, now we have disintegrate it into different entities. So therefore in 2001, the transmission that was previously done by WAPDA, that transmission part of the WAPDA is being constituted as a separate company, which is now known as National Transmission and Dispatch Company. So NTDC, or National Transmission and Dispatch Company, is now responsible for transmission 220 kilovolt and 500 kilovolt transmission in Pakistan. And its head office is in Lahore, at Abbott Road, and its control center is in Islamabad, opposite to Beacon House, Magla campus, in H8. Then the distribution, the WAPDA that also take care of the distribution at that time. So the distribution side of the WAPDA was also disintegrated into different companies. For example, for Islamabad side, they have made Islamabad Electric Supply Company. For Lahore region, they have made Lahore Electric Supply Company. For Gujranwala, Gujarat, Wazirabad, Lala Musa, and this Hafzabad, Pindi Bhattiya, Kamo ki, Sado ki. They have made Gujranwala Electric Power, Sialkot even, Gujranwala Electric Power Company. Then for Murid from Murid to Lahore city itself, Shadra, Raiband, Phoolnagar, Changamanga, Fort Radha Kishan, up to Patoki, and then up to Saiwa, they have made basically LESCO, Lahore Electric Supply Company. And for Faisalabad, Jhang, Sargodha, they have made FESCO, Toba Texin, Kamalia, Rajana, Sundri. From these areas, they have made FESCO, Faisalabad Electric. And from Saiwal to up to DG Khan and Rajanpur, they have made MEPCO, Multan Electric Power Company. And from Sakhar to up to that Hyderabad, they have made HESCO, Hyderabad Electric. Now they have also made Sakhar Electric Power Company. And for Karachi, entire Karachi, they have made KSC Electric, Karachi Electric Supply Company. For Peshawar, whole of the KPK province, they have made Peshawar Electric Supply Company. For whole of the Balochistan province, they have made Quetta Electric Supply Company. And now PESCO is also divided into, one is PESCO now and another one is TESCO, tribal areas, Electric Supply Company. So students, see, the one WAPDA which was responsible for transmission, which was responsible for distribution, now that distribution is further disintegrated to 7-8 companies, distribution companies, looking after each and every region. That transmission company, which is only looking about 220 and 500 kilovolt transmission lines. Now WAPDA is remain only with WAPDA Hyder and WAPDA Thermal. Now the generating station which are running on water and the generating station which are running on oil, furnace oil, and owned by WAPDA, those are the generating stations that the WAPDA is currently running, and WAPDA is restricted to generating stations, dams, and these furnace-based power plants. Then those are known as WAPDA Thermal and WAPDA Hyder. Now, Tarbela, if somebody is doing job in Tharmela power plant, he is the employee of WAPDA. If somebody is doing job in Mangla power plant, he is the employee of WAPDA. If somebody is doing in job as a SDO distribution in Islamabad distribution company, he is not employee of Vodafone. He is employee of Islamabad electric supply company. If somebody is doing job there in Lahore in distribution company, he is not employee of Vodafone. He is employee of Lahore electric supply company. If somebody is doing job there for transmission line, he is employee of National Transmission Dispatch Company. So what they have done is that basically they have disintegrated a main big WAPDA company into three entities. One is looking after transmission, the other one is looking after distribution, and the other one is looking after the generation side, and there are a few other private generation companies that are also involved. So this was the major restructuring done in our power system in 2001 and 2002. But there was a loophole in all this restructuring. What was that loophole? What was that loophole? What was that loophole? That loophole is that yes, we have disintegrated the WAPDA into different distribution companies. Yes, we have disintegrated WAPDA into transmission, and yes, we have disintegrated WAPDA into thermal and hydel. But see, all these are son and daughters of a single parent. All these son and daughter of the government of Pakistan. Yes, Islamabad Electric Supply Company has been made, had been made, but who owned that company? Who owned Islamabad Electric Supply Company? Who tell me? Who will tell me? Me, you, or government of Pakistan?
Government of Pakistan.
प्राइवेट नहीं
No, it's not private. Currently, it's not private. Who own National Transmission and Dispatch Company? Government of
Government.
Pakistan. Who own WAPDA Hydel? Government. Who own WAPDA Thermal? Government. So, students, 1 minute. Just a minute. Yes, Hassan. ठीक लो तो है ऐसे साहब भी नहीं किधर है इनाम साहब भी नहीं आया आना भी नहीं उन्होंने दूध कितने का आएगा 500 का मैं 1000 ले लो ना मेरे से तो फिर देख लेंगे इसको जो करना है ठीक है ले आओ जो भी है टी बैग और वैसे क्या लोगे उसको खाने में क्या लोगे खाने में यार कुछ और ले आओ और कुछ ले आओ क्या लोगे वैसे क्या मिलता है तो नान छा नहीं लेना काफ़ी दिन हो गए नान भी नहीं आए और नान ले आना चने नान चने भी मिलते थे एक दफ़ा हम लाए थे हाँ वो ले आना थोड़े से बंदे तो थोड़े से कितने पता कर लेना देखना जाते हो ना 5-6 नान ले आना और थोड़े से चने ले आना उस दिन के साथ में 2-250 के सही है ये लिख लेना अच्छा यस स्टूडेंट सॉरी वो हमारे वो टी क्लब के आगे थे मेंबर तो हमने कुछ अरेंजमेंट करनी थी ही वाज आस्किंग मी अबाउट समथिंग तो अच्छा yes students so what I was talking about what I was discussing yes I was discussing about traditional utility and regulated so I was saying that who own NTDC government who own WAPDA Hydel government who own WAPDA Thermal government who own all the distribution company except KESC is a privatized distribution company all other distribution companies other than KESC they all are government owned. So we have done, so if there will be any loss in ISCO, who will bear that? Just take an example कि अब्बा ने बेटे को बिजनेस करवाया और ऐसा हुआ कि the son has to face a loss in the business. So when the son will come back to the home, as he has the face the loss, so who will ultimately have to bear the loss? बेटा तो बाहर जाके वो जो पैसे दिए थे अब्बा ने, उनके जाके लॉस, उसने कोई बिजनेस किया, बिजनेस में सक्सेसफुल नहीं हो सका, लॉस हो गया उसको। अब ये है कि एक तरीका तो ये है कि उसको घर बैठा लिया जाए और आप भाई कुछ नहीं करना आपने। अदर वे क्या होगा कि जब उसके फादर को पता चलेगा कि दिस हैपेंड, तो वो क्या होगा, फादर क्या करेगा, दोबारा उसको पैसे देगा, ऐसे ही होगा ना। तो उन्हें कहेगा अच्छा चलें, आपको लास्ट टाइम लॉस हो गया, आप और पैसे ले लें थोड़े से और जाके कोई बिजनेस और कर लें या यही बिजनेस कर लें और इसमें दोबारा पैसे इन्वेस्ट करें और देखें कि आपको इस दफ़ा रिटर्न आता है कि नहीं आता। ऐसा होता है या नहीं होता? ऐसा ही होता है नेचुरली, तो ऐसे ही होता है, मतलब मोस्ट ऑफ द टाइम यही हो रहा है ना। स्टूडेंट्स, कैन यू हेयर मी?
Yes, sir.
आपको मेरी आवाज़ आ रही है स्टूडेंट्स?
Yes, sir.
सो हैव यू गॉट माई पॉइंट? आई हैव डिस्कस, जो मैंने पॉइंट आपसे डिस्कस किया कि क्या कि अगर एक बेटा है और उसको जो वालिद हैं उसके वो पैसे देते हैं कि आप जाके बिजनेस कर रहे हैं, उसे लॉस हो जाता है बिजनेस में, तो नाउ देयर आर टू वेज कि एक तो ये बेटे को घर बैठा लिया जाए और उसके बाद उसे कोई काम करने को ना कहा जाए। तो दूसरा तरीका ये है कि उसको दोबारा बाप क्या करता है कि चले यार दिस टाइम आपसे लॉस हो गया, नेक्स्ट टाइम फिर उसको वो पैसे देगा, यानी कि वो लॉस अल्टीमेटली किसको बेयर करना पड़ता है? बाप को ही बेयर करना पड़ता है, उस फादर को बेयर करना पड़ेगा ना उसके, वो जो लॉस हो रहा है। ऐसे ही है। तो द पॉइंट हियर इज दैट कि अब हमने कंपनीज तो बना दी, सन एंड डॉटर्स तो बना दी है, आईएस को भी बन गया, लेस को भी बन गया, लेकिन ओन इन्हें कौन कर रहा है? हु इज ओनिंग देम करंटली? Government owns them. If anybody will make a loss, if ISCO will make a loss, if LESCO will make a loss, who will have to bear that loss ultimately? Who will have to bear the loss? Government of Pakistan. So we have made these companies to basically make the system more efficient, reliable, cost effective, economical, less losses, profitable, various things in the world that people do it. But after restructuring, the same is happening with me that was happening before 2000 there. Previously, the WAPDA was in loss. Currently, the distribution companies are in loss. So, what the benefit that we want to seek from this restructuring or disintegration or division of these different wings of the WAPDA, those have been not attained. So it means there is something that is somewhere problem that is currently existing and we have to resolve that problem. So we have tried to restructure our traditional utility system, but unfortunately we have not done it. Why? Because yes, we have make different entities or we have distributed the main water distribution into different companies, but ultimately those are still owned and regulated by the government of Pakistan. So if anything wrong happens, ultimately in one day, in 10 days, in 1 year, in 10 years, that loss or that liability have to be faced by the government itself. So I hope you have understood that what actually regulated industry means. Regulated industry is the one in which the generation, transmission and distribution is owned by the same owner. Generation, transmission and dispatch or distribution is owned by the same company. That power system industry is known as a regulated power system industry. And in deregulated power system structure or power system industry, the generation is owned by different private sector entities, different government companies, different government organizations, not one government organization, not by one private company. Different actors are involved in the generation. First. Secondly, the transmission and distribution itself sometimes is owned by some other stakeholders as well. Generally, the transmission is owned by the government or the main regulator. However, the distribution may have been adopted or may have been owned by the different private sector or different organizations. So this is the structure of deregulated industry. जो वर्ल्ड है, जो दुनिया है, वो डीरेगुलेशन में बहुत आगे तक जा चुका है और हमने अभी रिसेंटली एक पास तो किया एक डीरेगुलेशन के ऊपर, फर्दर डीरेगुलेशन के ऊपर एक लास्ट वीक एक पास किया हमने एक लॉ. आई होप सी के वो कहाँ तक जाता है. दुनिया में डीरेगुलेशन इस लेवल तक हो गई है स्टूडेंट्स के अब बिडिंग होती है पावर की. जैसे you go to the stock market, maybe you have seen in the 9 p.m. news at night, maybe when they were discussing about the stock market, the people are basically giving their bids for different shares. I will take this much share in that much amount. Similarly, in the world, the people are bidding for power. What is currently happening? That they make a pool of power companies in which they come and they basically share the amount of per unit they will charge for the power. Company X, Y, Z, A, B, C, L, M, R, different companies, they will come. They will basically post, similarly like in the stock market, they will post their per unit cost for this much time. That I will charge, company X will say that I will charge 30 rupees or 20 rupees or 15 rupees per unit from 9 a.m. to 11 a.m. Company Y will say I will charge 10 rupees from 1 p.m. to 3 p.m. per unit. Similarly, the customers are linked to that bidding site, linked to that bidding pool, and they have registered there as well. And most of the time, those customers are not the residential customer or the commercial customer. Those are the big industrial customers with a handsome amount of the load required. They see that this is the power pool and their bidding power at this is rate. At the same time, they will enter the pool, the load or the customer, electrical customer. They will bid the power or select the power at that rate and have a deal or purchase that much amount of the units for that time on the rate that they have bidded for that time. So this is currently happening around the world, even in India as well. Similarly, the distribution networks have been laid by 2 or 3 different companies. Just like maybe you have observed a cable operator in your area. If you have multiple cable operators in your area, then I'm sure that you will have a good cable quality. The quality of the channels or the broadcast that is being seen at your home will be of very good quality. And at the same time, you will have less amount of bill if 2 or 3 different cable operators are operating in your area. In Islamabad, Rawalpindi, generally in one area only one cable operator is operating most of the time. However, if you go to Lahore or the central Punjab side, I don't know about the south side, but I am sure about central Punjab side. Generally 2 or 3 cable operators operate in the area and they have their own packages for a home. One will say that I will give you that much number of the channel. The other will say that I will give you HD quality. The other one will say that I will charge you less amount of money. And the other one will say that I will not take any security from you. I will not take cable charges from you. There are various packages that they will offer you. Why they are offering various packages? Because they have a competition, they have a healthy competition, and they want to basically have their connection to be installed there, and they are in the market. But if there will be only one cable operator, he will charge on its own condition. He will give maybe limited number of all the channels. He will not give a good quality because he know that nobody other can operate in this area. Only I am operating in this area. I will not have any competition with anybody else. So therefore, this is my monopoly and I can do anything that I want to. So therefore, the customer or the consumer will have to suffer. We can take also example of this mobile phone transformation or cellular phone transformation in Pakistan. Before cellular transformation in 2002, 2003, maybe you remember that or not, maybe you have heard that. There was only PTCL, and you have to wait 1.5 years or 2 years to have a telephone connection at your home. And for that telephone connection, you have to submit a huge amount of security amount, and you have to wait, and you have to visit number of times to the PTCL office and many things. But after the arrival of the mobile phone, GSM, and various wireless technologies, now rarely you will talk about PTCL, rarely you will discuss about PTCL. You have in your hand various options of different operators. For example, you phoning saying that I have this package, this is a ladies package, and this is a something like that package. Telenor is saying that I have this package. You can do this number of SMS and that amount of calls. Similarly, Zong is saying number of offering various packages. Somebody is good in internet, somebody is bad in internet, somebody is good in call quality, somebody is good in coverage. There are various positivities and negativities of each and every provider. So you can opt of your choice. So, but this choice is not available in the electricity industry currently in Pakistan. You have one distributor, that is ISO. If you will not get power from there, if they want, they can switch off your power for 6 hours in a day. If there any fault occur, they may not repair the transformer for 2 or 3 days. If something else occur, for example, maybe they will make you, they will pay you more bills. They will not basically facilitate you in paying the bills, and there are various others. They will not basically facilitate you when you will go to the office, because they know that this is your responsibility, this is your problem. You have to suffer because you don't have any other option, and you are on their mercy. So therefore, if multiple operators come in an area to supply electrical power, then surely each and every of them will improve the quality of the power. They will increase the reliability of the power. They will give you various packages that if you will use power in this time of the day, the per unit cost will reduce. If you will use this power this time of the day, the per unit cost will enhance. If you will save the units in this is the time, I will give you a gift package. If you will do it, will give you another 100 units free. Well, they can offer you various packages. Fine, because there will be competition. So restructuring has benefits, deregulation has benefits, healthy deregulation and planned restructuring offer you many good things. So currently in Pakistan, we have tried to restructure our system, but it is not an exact restructuring. Why it is not exact structuring? Because all the liabilities are currently faced by whom? Who is currently facing all the liabilities? Yes, students, are you in the class?
तेनों क्यों लकवा हुआ है?
यस सर।
सॉरी, क्या कह रहे थे आप? मुझे सुना नहीं पहले, क्या कह रहे थे आप? कुछ और भी बोला पहले।
सर वो गलती से किसी ने बोला भी चला गया तो माइक ऑन था, दूसरे रूममेट के साथ लगा हुआ।
Okay, fine. So I hope you have got the point that what is the difference between a regulated and deregulated industry and regulated structuring and deregulation. Now, if we take in Pakistan, see that I have quoted an example here of Pakistan, the power industry deregulation. In Pakistan, we have basically traditionally 6 structures into independent business. We have made Gencos, we have made power market, transcos, transmission companies, independent system operator, retail services, etc. So now, can you now answer the following questions? First of all, who will answer? What are the main components of power system? After studying this lecture, who can answer that?
Generating point,
Generating
transmission
होता है,
lines,
transmission
distribution, and
होता
then
है,
load.
distribution.
Good. Name 5 sources used for electric power generation.
सर टाइडल हो गया तो उसमें ऑयल पावर प्लांट हो गए और हाइड्रो इलेक्ट्रिक पावर प्लांट हो गए इसमें।
ये 3 हो गए, 3 हो गए और 2 रह गए।
और
टाइडल हो गया
न्यूक्लियर
आपका,
पावर न्यूक्लियर सर पावर प्लांट होता है।
4 हो गए। फिफ्थ वन
कोल पावर प्लांट।
कोल पावर प्लांट सर।
हाँ, कोल पावर प्लांट। ओके, गुड। व्हाट इज द ब्रेकअप ऑफ 6 स्ट्रक्चर फॉर सिस्टम रिस्ट्रक्चरिंग? दीज आर द 6 स्ट्रक्चर्स: जेनकोस, पावर मार्केटर्स, transmission company, transcos, independent system operators, retail service providers, and distribution companies. Write names of power transmission equipment. Can anybody name power transmission equipment?
ट्रांसफार्मर सर।
Good.
Copper,
Good.
insulators,
lightning
transmission,
arresters,
स्टेप अप ट्रांसफार्मर।
Bearings.
Step down
sir,
transformer. Step down transformer होंगे ना? What are the power quality considerations? What are the power quality considerations? Who will tell me? There were
less
2 power
losses होनी
quality.
चाहिए
नहीं, power quality.
सर, frequency and voltage.
Yes, frequency and voltage. And what was that consideration? Frequency should not be less or greater than what?
50 सर, 50
49.5 से greater नहीं होनी चाहिए।
And voltage in per unit? And voltage in per unit?
0.5 से less नहीं होना चाहिए और 1.05 से greater नहीं होना चाहिए।
In per unit. In per unit. What? In per unit. Okay, good. Now, I think we should wrap up the lecture now, because I have not given you the break and it is almost 2 hours and 30 minutes now. Thank you very much for being in the class. I hope you have got my lecture. If you have any question, friends, please let me know. I will answer your each and every question. Yes, friends, have you any question?
slides send कर दें please.
Yes, I will do it, inshallah. I will upload it in the Teams. Okay, wait.